So I think once you already know how to go from name to formula, going from formula to the name, it's kind of easier. So let's say that somebody was like, okay, write the name for this formula. Well, I notice that this is between parentheses, meaning that it's probably a polyatomic ion. So I'm going to go and find NH4 plus NH4Cl, or sorry, NH4 between parentheses. I can see that in my chart I have NH4 here, and that is called ammonium. So I'm going to, for this first part, write ammonium. And the next part is a Cl. I know that Cl stands for chlorine. And so I'm just going to write my naming convention for a nonmetal and metal for an ionic compound, which ends in "ide", so chloride. And that is it for this one. So what you have to pay attention for is that you don't have transition metals in here, because if you do, remember we have to put like a little parentheses with some kind of Roman numeral in the middle, or else it is not correct. But because NH4Cl, neither of those are transition metals, meaning the elements in the middle of the periodic table, I don't have to worry about that. So all I did was find this polyatomic ion, name it ammonium, and then it ends with chlorine, and I know that this is an ionic compound because it's a metal and non-metal bond, so it ends in "ide", ammonium chloride. All right. So let's say that somebody was like, okay, write the name of this compound. So I know that Mg is magnesium, and it is right here. So I'm just going to write magnesium. I notice again that there is something in parentheses, so that suggests that it is a polyatomic ion. I look at my table and I can find that, whoops, right here, that matches that polyatomic ion that I see, and the name of that is hydroxide. So I'm just going to write hydroxide. Hydroxide. There are no transition elements here at all. There's no elements that I got from here, only magnesium and my polyatomic ion that's hydroxide that I never have to worry about being a transition metal. So that's my answer, magnesium hydroxide. Okay, let's do one more example. Alrighty, whoops, sorry. Let's say that someone's like, okay, draw the name for this one, write the name. Sn. When I look for that in my periodic table, Sn, where is it? Ha! It's right here. Sn. It is not in the transition metal block, but it is in this row where the ion formation gets kind of wonky. So this row will always be a +1, this row will always be a +2, this row, I keep saying row, column. This column will be always +3, this one will always be a -3, -2, -1. But this one can kind of go positive or change up the number of electrons that it'll gain/lose. So 10 is one of those special ones that we need to do the parentheses with some kind of Roman numeral in the middle of the name. So I see Sn is 10, so I'm going to write 10. It's the first part, just identifying my elements. And I know I have to have a parentheses in the middle because it's one of those weird elements. And then ClO2, well, that looks like a polyatomic ion. It is in the middle of parentheses. ClO2. Oh, found it. ClO2 is chlorite. So I'm just going to write chlorite. So how do I find out the number that goes in here? Well, I know that because this is a metal and non-metal bond, metal, tin, non-metal, this whole thing, it's going to be an ionic compound. Ionic compounds I know will trade or steal electrons. So if this compound, there's 3 of it, and this one there's 1, so there's 1 of this one, and there's 3 of this one, they are going to switch up their electrons. So Sn is going to end up with 3, so tin is going to end up with 3, and chlorite is going to end up with 1. So that is how I figure out the number that goes here. Tin is going to end up with 3, and that is the number that, the Roman numeral that I'm going to put in the middle. So that's the answer for this one.